Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called SVS 445 XY Cages by Richard. And here are the rules. We need to apply classic Sudoku rules, which means in every cell on the grid, place a single digit from 1 through 9 such that every row, every column, and every designated 9-cell region contains the digits 1 through 9 once each. Exactly once each. Digits in cages may not be repeated, and each cage has a sum that can be derived by adding all the digits it contains. So basically, yeah, each cage has a sum from adding up the digits that are in the cage, and there are no repeats in cages. A diamond between two cages indicates that their sums have a difference for white diamonds, or a ratio for black diamonds that is equal to the topmost in case of a column, or leftmost in case of a row, digit of the column or row in which the diamond is placed. And not all possible diamonds are necessarily placed. Okay, so if a diamond, sorry, not a diamond. If a, yeah, it's a diamond. If a diamond is placed in a row, right? Like this is placed in a row, this is placed in a row, same as this. And it's a white diamond. Okay, let's use white diamond. So this is placed in a row. That means the difference between the sums, the sums of the cage must have a difference that is equal to the leftmost cell for the row, if the white diamond is in the row. So say this was like a 5. That means the sum of this cage and this cage would have to be a difference of 5, right? So one of these cages is equal to the other cage's sum plus 5. And that's how white, so say this was 5. Then again, this cage would basically have to have a difference of 5 from this cage. Also, since this is 5, and there's a black diamond here and here, that means this cage has a 1 to 5 ratio with this cage, the sum of this cage, right? We don't know what it is, what the ratio, we don't know which ones are which ratio, but we know this has a 1 to 5 ratio if this is a 5 to this, or 5 to 1. 1 to 5, 5 to 1, we don't know how it goes which way. Same with this. This cage has a 1 to 5 ratio with this, or 5 to 1 ratio in some order. Because 5 is the digit that is the leftmost digit in the row. For columns, if you had, say, like a 3 here, these cages would have a difference of 3 because there's a white diamond in that column and separating these cages. And these cages would have a 1 to 3 ratio because this diamond has 3 as the topmost cell in the column. So that's how that works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Interesting. We have double black diamonds here, which means the ratio between this digit and the sum of the rest of these digits has to be whatever that is, but it has to be exactly the same as that digit. So we're going to mark these as the same digit. Okay. What else do we have? This cage is going to be in a certain ratio with this cage using that digit. This cage is going to be in a certain ratio with that cage using this digit. And they're different digits, obviously. So obviously this can't be 1 as a digit. So the ratios we have are 1 through 9. The differences we have are also 1 through 9. Hmm. So the question is, what are... I think the ratios are going to be more restrictive. The differences could... I mean, they... we don't really have that many different... Okay. 4 to 2. Can you ever have a 9 to 1 ratio? Possibly, yeah. Hmm. That's interesting. Can this be 1 to 1? I think it can be, right? Uh, hmm. Not really sure how to attack this because this is very interesting. Let's mark every digit in row 1 and digit in column 1, which are useful. So we have here for this and this. We do have that one. So actually, let's make that light. Let's make it all green actually to start with. This is important. This is important. That's obviously important. This doesn't have one. This does. So does this. So does this. And obviously this does. And it has to be the same ratio. Because these are going to be the same ratio. Column 2 doesn't have one. Column 3 does. Let's mark this as pink so that we can differentiate. That's pink. Pink here. Nothing column 4, nothing column 5, column 6, column 7, and column 8. Oh, that's interesting. Hmm. So those are the ones we probably want to focus on. Hmm. Maybe these two. What's the largest you could have difference between these you could have? It could be 3 to what? 17? Between a 2-digit number and a 2-digit number. Yeah, so you could have 3 to 15. So you could have a 5 here. Obviously, you could have 1. You could have 1, I think 1 through 5 here. Yeah. All of those seem to be okay, right? Because it's a 1 to 2 ratio. This is 3 at most, at least 17 at most. So you cannot have 1 to 6. 24 to similarly, this is 24 to 3 at minimum, at maximum. So that would be 1 through 8. That's interesting. 2 to 4. That could be the full 9. But you can't really have 8. If you have 8 here, this can't be 7, 8, 9, adding up to 24. So you could have 7, 1 to 7 here. 1, 2, 3, so 6 to 24. That's the thing, though. It would have to include itself, which is kind of weird. So can you ever have 9 here? I don't think so, right? 9 plus 1 and 2. 9 plus 1 and 2 is 12, and that can only be matched with 24. So 9 can't be here. What about 8? 8, 1 and 2, no, to 24. 7, 7, 1, 2 is 10, so no. 6, 1, 2. That's 9 versus 24. Nope. 5, 1, 2 to 24. 5, 1, 2. That's 8 to 24. Nope. 4, 1, 2. It's 7. 7 times 4 is 28, so no. So this is 1, 2, or 3 here. 3 can work. 3 could be with 1 and 2, which would add up to 6. 6 to in the 3 ratio, or even 1, 3, 4 works. That's interesting. Okay, so this is 1, 2, 3. 3 to 3 ratio is 6 at minimum to 24. So this is 1 through 4 here. This could obviously be 4 to 3. What's the largest this can be? 6 to 1. Sorry, 7 digits to 1. What's the smallest that could be? 7 to 1. So say you had a 9. 7 to 1 is 28. So you can't quite have 3 to 1. You could have 4 to 9 potentially there. So this is 4 to 9, which is the same here, 4 to 9. Right? 28 to 9 is greater than 3. So you can't have less than 4 to 1 ratio. Okay. Can you have 9 to 1 here? No. Right? 10 times 9 is is 90. So 9 and 1 to 9 to times to in a 1 is 9 ratio with this would be 90. 8 to 1. If you have 8 to 1, that's 9 times 8, 72. So no. 7 to 1. 7 to 1 ratio. Oh, this is a difference here. Well, it's 2 and 3. Interesting. Yeah, that doesn't tell us too much. 7 to 1 is 8 times 7. That's not possible. 6 to 1, 6 times 7. That would be 42 for 4 digits, which is not possible. So it's at least, at most, 5 to 1. So say you had 5 and 1 here. That's 6 times 5, which would be 30. So that is possible. Interesting. So these digits, so one of these is going to be less than, okay. Huh, that's interesting. So this has something similar, right? So this is 1 through 5 also. Because it cannot be low. It cannot be higher than 5. So say you did have a 5 and 1, and then this is 6, 7, 8, 9. What would the other ratio be, right? So 5 to 1 kind of works, right? With 6, 7, 8, 9. Then you have... So it'd be 30. Could you have a 4 to 1 ratio? No. Could you have a 3 to 1 ratio? Yes, but it would have to be 3 and 7, and that's not possible because we have 6, 7, 8, and 9 here. So I don't think 5 is actually possible here then. So 5 and 1 only works if it's... So 5 is a ratio valid with 1 and 5. But that only works if this becomes 6, 7, 8, and 9. And that doesn't work then with this other ratio, right? Because you can't have 5 there, obviously. 4 doesn't work. 3 would only work if this is adds up to 10, but that would be 3 and 7. And we already have a 6, 7, 8, 9 here. And same with 2. 2 doesn't work because it'd be 15. So this cannot be 5. So yeah, as I figured, it was going to be these ratios, which was probably going to be very important. 4 to... I don't think this can ever be 1 here. No, this can't be 1. If this is a 1 to 1 ratio, this is at most 6, and 4 digits can never add up to 6. So this can't be 1. 4... Can it ever be... This could be potentially 1. No, this cannot be 1, because that would again be 1 and 9. So that would have to be... So if this is 1 and 9, that would be 10, and this would add up to 10, but we have to add up to 10 with 4 digit without a 1, which is not possible. So it cannot be 1. So these are in ratios of 2, 3, or 4. So we're guaranteed this is an even. This is probably even. Yeah, because you can't have 2, 8, and then this adds up to 5, right? So this has to be an even amount here. Because we can't have 3 and 3 both be here. Okay, what about 4? If you have 4 and 1, then this is at minimum 20. So that's possible. 4, 1, and 2, 8 would be valid. Can you have 4 and 3? If you have 4, 2 here, can you ever have 4 and 5 here? So 9 times 4. Well, you could have 2 and 5 potentially here. Yeah, that would work. Yeah, I was hoping I could limit that, but I guess not. Um, hmm. Can this actually ever be a 9 to 1 ratio? If this is 9 to 1, this is at minimum 3. And this is at maximum 5, 6, 7, 8, which is 26, so not quite. So this has to be 1 through 8. Still could be 8. Okay, so let's still try. So 4, can 4 and 3 be in that scenario? Obviously the 4 would have to be divisible by 3. Could it be 4 and 5? So I think this is always guaranteed to be a 2, right? If we have 4, 4 works with 2. And if we try to have 4 and... We can't have 4, 5, and 3. I don't think that works. 4 times 4 plus 5 is 9. Times 4 is 36. No, so that does not work. So it would have to be 4 and 2 here. So we're guaranteed one of these is going to be a 2. Right? It's either 2 and 4 as the ratios, or 2 and 3 as the ratios, or if we try to have 3 and 4 as the ratios, 4 must add with 2 to be in a valid ratio there, right? So 4 plus 2, 6 times 4 is 24. So then this would have to be 3 and 5 as the other one. So we're guaranteed a 2 in one of these 4 cells. So that eliminates 2 in the rest of the region. Can you, though, actually have 4, 2, and 3? So 4 and 2 is 6 times 4, which is 24. So this would be 24. 3 would then be 24 to 8. 24 in the 3 to 1 ratio would have to be 3 and 5. So we have 2, 4, 3, 5. This adds up to 24. So 24 plus 8. 24 plus 8 is 32. Plus 6 is 38. And then we have 7. So that could be valid. So this inside here would be 1, 6, 8, and 9, which does add up to 24. So 7, this is a 1 to 7 ratio. Can it ever be? It could be 4. So it's either 7 with 2, 4 or 3, 5 here. That's interesting. 7 with 2 and 4 is 13. Right, so 7 with 2, 4 is 13. 45 minus 13 is 32. That's not going to be a 7 to 1 ratio. Oh, wait, no, it could be 28 and 4. Actually, I think that does work, 28 and 4. So 5, 6, 8, and 9. And then 1, 3. 5, 6, 8, 9 adds up to 28, which is in 1 to 7 ratio with 4. Yeah, that works. Okay, so this could be, that actually could work if this is, so this is, if this is 2, 4. What happens if it's 3, 5? 7, 3, and 5 add up to 15. So 15 means this is 30 in a 7-to-1 ratio. So that would be divisible by 8, and that's not possible. Okay, so... Okay. Okay, so one thing is for 2... Yeah, okay. So if this is 7 and this is 2, 4, it has to be... If this is 4 and 3 in a ratio, this has to be 2 and 4. And this would be 1, 3, 5, 6, 8, 9. And that does work. So this would have to be 7, 3, 5. This would be 8. These would have to be double, including this adding up with one of these must equal the other one. So this would have to be double, which would mean this is an odd digit. So it would have to be 9, because we have 3, 5 here. So we're just trying this out. So we have 4 and 2, 3 and 5, right? 3-to-1 ratio times 8 is 24. 4 plus 2, 6 times 4 is 24, so that works both ways. And this has to be 7 then. Because 24 plus 6 plus 8... 24 plus 8 is 32, plus 6 is 38. 45 minus 38 is 7. So this works if this is 1, 3. This has to be, what, 5, 6, 8, 9. This looks like it's actually pretty potentially valid. This can't... Okay, so this has to be an odd digit because, again, 7 plus these... One of these plus 7 is equal to the other one. It could be this one plus 7 is equal to that. But then... So then this 8 is even. These are even. So to add up to 45, this has to be odd. So this is 9. This is a 9-to-1 ratio then. Okay, so this looks all valid. Obviously, 3 cannot be here or here. We have what? 1, 2, 4, 6, and 8. So this could be a 1, 2, 4 triplet here, and this is 6, 8, and that would work. Okay. So this is all looking valid, and it's probably the solution would be my guess. Let's look at other possibilities here. So it could be 2 and 4 or 2 and 3. If it's a 2-to-4 ratio, the 4 has to be double the amount that 2 is. Okay. That means whatever digit is with the 2 has to be doubled also with the 4, right? And the reason why we know that is, say this is like 2, well, can't be 2 what? Oh, that's going to be tough. Say it's 2, 3, right? That's 5. 5 times, it can't be 2, 3. Oh, no, never mind. That's not going to work. It's going to, oh, that's weird. Okay. The 2 value has to be greater, has to be double the value of 4. So say you had 4 and... Okay, so you cannot have 4 and 3 in that situation. So we've shown what 2 and 4 has to be. Or 3 and 4, sorry, has to be. What about 2 and 4? Say we had 2, and then we have 4. You could have 4 and 1, which means this is 5. And then this would have to be 5 times 4, which is 20. Can you ever have 4 and 3? And I think the answer to that is no. If you have 4 and 3, that's 7. 7 times 4 is 28. So then the 2 would have to add up. 28 divided by 2 is 14. And 2 plus another digit is never going to add up to 14. So it would have to be, if it's 4 and 2, it has to be 4 and 1, which is 5. So you're going to have 4 here and 1 here. This then is, so this is 5 times 4 is 20. This must then be 2 and 8. So we have 20 plus 10 plus 5 is 35. And we have a single digit, which would have to be 45 minus 35, which is 10. So that 4 and 2 does not work. What about 2 and 3? That's going to be interesting. So the most this can be is 5. So, and 2 and 5 is not going to work with 3, right? If you have 2, 5 here, that's 7 times 2 is 14. And then you can't have 3 divisible by 14. Or 14 is not divisible by 3. So we have 3 and 5 here. So I think either way, this is 3 and 5 then, right? You can't have anything smaller. So you can't have 2 and 4. Because 2 and 4 would mean this has to be 12. Which is too small, right? 12 without a 2 adding up to with 4 digits is never possible. So you have to have 3 here and 5 here. So this is guaranteed to be 3 and 5, interestingly enough. So this cannot be 3 or 5. Because we tried it with 4, that works. Now we're trying it with 2. 3 to 5 in a 3 to 5 ratio. So 8 in a 3 to 5 ratio is 24. And then you would have to have 2 that adds up to it, and that doesn't work. So we know then this has to be 3, 5, and this has to be 4, 2. And then this is 7, so then everything flows from that. So this cannot be 3, this is guaranteed to be 9. This is a 1, 3 pair, so then this has to be 9 here. This has to be 5 or 6. And this is 5, 6, 8, 5, 6, 8. So this is in a 5 to 6 ratio with these 3 digits. This is in a 5 ratio with these 2 digits. So this is at minimum 2 and 4. That's 6 times 5 would be 30, and that's not possible. So this has to be the smaller one, and it probably has a 1. This is 1, 6, 8, 9. So we have 24 here. That's in a 3 to 1 ratio with this cage. It can't be 24 times 3, so it's 24 divided by 3. So this is 8. And you cannot have a 1 here. So this must be 1 through 5 here. This can't be 1 or 3. So this is 2, 4, or 5 here. Which means if we have a 4, we have guaranteed 1 here. If this is 1, 3, 4 adding up to 8, this must be 1 and 3, and that's 4. Otherwise, it's 1, 2, 5. This is in the 5 to 1 ratio. It cannot be 1, 3. If it's 1, 3, that's 4 times 5, which would be 20. So this has to be a 1 and a 2 here. Which means this adds up to 15. 3 times 5 is 15. So this is 6, 9, or 7, 8 here. Okay. This is 3, and it has to have a difference of 5, 6, or 8. I think all of those work. This has a difference of 3 with this. So we have 1, 2, 4, and 6, 8 left. Okay, this can't be 1. So 1 has to add up to 7, and the other must add up to 14. So can this ever add up to 14? 2, 4, 8, and 1, 6 does work. So this can only add up to 7 if it's 1 and 6. So that would be 1 and 6 there. This can add up to 14 if this is 6 or 8, right? So this can never be 6. This could be 2, 4, and 8. That is possible. But if it's, yeah, it could work. That could work. Wait, can this be 1, 2, 4? Yes, if this is 14. Can this ever actually be 1 then? If this were 1, this would guarantee this is 6, 8. This is 1, 2, 4 adding up to 7, and this is a 1-to-1 ratio. But then this can't be 1, 2, 4 because of the 2 in the column. So this can never be 1. This has to be 2. So this is 2, which eliminates 2 in the rest of the column. This is a 9-to-1 ratio here. Okay. What does that mean? Cannot be 2 times 9. That's 18, which 7 digits can never add up to. Cannot be 3 times 9, because that's 27, which is less than the 28 7 digits must add up to at least. So this has to be 4, right? Can't be 5 times 9. 5 times 9 is 45, and 7 unique digits cannot be add up to 45. So this is 4. So this is 36 here, which forces this then to be 5. So this is 5. This is 5, so this can't be 5. This is 6. Interesting. So this adds up to 18. Okay. Or this is in 6-to-1 ratio, and this adds up to 18. This is 2-to-1 ratio. Okay, so say we try to have this as 14. 2, 4, and 8, then 2-to-1 ratio is 28, which 3 digits can never be. So this has to be 1 and 4. This must be a 6-8 pair. 7, that means this adds up to 14 without a 2. So this is 14. You can't have a 4-to-1 ratio with 14. So it has to be 1. So this must be 1. This is 4. This is a 1-to-1 ratio. So this is 14 also. That means 1 cannot be here. So that means this has to be a 1. Okay. This is a 2 to... Okay, so this is 14. 14 here. This is a 1-2 pair, so this cannot be 1 here. So this is this adds up to 15. And if it's 6, 9, these would both be 8, so that's not possible. So this has to be 7, 8, which eliminates 8 in the rest of the row and 8 in the rest of the column. So this can't be 6 or 9 because of the 6, 9 pair in the box. So this is 7, 8, which forces this to be 3 or 4, 3 or 4. This can't be 4 because of 4 in the column. So this is 3. This is 4. The 7, 8 pair eliminates 7, 8 here. So this is 5, which makes this 8. This can't be 4 or 5, so this is 2, which makes this 5. To add up to 8. Okay. Remaining digits of row, let's do here. This is 6 and 9 in box 2. This is 15 then. It has a difference of 3 with this, right, which is 18. We do know that that's correct. So this has to be 4, 5, and 7 remaining in row 3. This can't be 5. This can't be 4 because of the 5 and the 4 respectively in the column. This has a difference of 8. So this is 3 plus 8, which is 11. Okay, so that means this is 11. So it could be 7, 1, 3. 155 does not work. 1, 4, 1, 4, 6 does work. Or this is 2. It can't be 2, 3, 7. It could be 2, 4, 5. So it would be 2, 4, and 5. So yeah, there's that. Okay. This is 15. It has a difference of 5 from here, and that can't be 20, so this is 10. So we have no 1, 9 because of the 1 in the box. It could be 2, 8, 3, 7, or 4, 6. We're not sure which. So this is 15, this is 10, this is 18. 10 and 18 have a difference of 8. So this is 8. That makes this 6. So this can no longer be 6. Can no longer be 6. So that means this can't be 4. This can't be 6. So it can't be 1, 6, and 4, but it still could be 2, 4, 5. So either this is 1, 3, 7, or this is 2, 4, 5 here. Okay. This has to be a 5-to-1 ratio. This cannot be... Well, yeah, it could have been 1 through 5 here. But this 2 means this can't be 1 and 2, adding up to 3. This 1 eliminates 1 here, so that's 3, which makes this 1. Remaining digits in column 4 are 5 through 9. No 8 here, no 5 here, no 9 here. 5-to-1 ratio. 5 digits adds up to at most 35 because there are no repeats, right? Yeah. So it's at most 35, which means this is at most 7. So it's 1, 6 at most. This can't be 1. These can't be 2. This can't be 5. This can't be 6 because that would make this 3 and 6. We have to have a 4 somewhere in row 8. Cannot be here because of 4 in the box. Can't be here because 4 in the box. So it has to be one of these two. Can you have 4 and 3? Yeah, I still could. So this cannot be 5 or 6 because that adds up to greater than 7, which this cannot be. Obviously 4 and 1 are fine. Okay, this cannot be 5, 6, 7, 8, 9. Because if this is 5, 6, 7, 8, 9, all of these see this cage here, which is guaranteed to have 6, 7, or 8. Okay, 8 can't be here because of 8 in the row, so this can't be 2. But this cannot be 5, 6, 7, 8, 9, because one of these has to be 6, 7, 8, and both of these cells see all the cells in this cage. So this has to be 4 and 1. Because if it's 3 and 4, that makes this 35, which means this is 5, 6, 7, 8, 9. So 4 is here, 1 is here, 1 can't be here. Again, this adds up to 18 without 5 or 6. That's interesting. You have to have 4 or 7. So that removes 1, 8, 9 as a possibility. It could be 2, 7, 9 still. So 2, 9, 7 works. 3, 8, 7 works. So those, what other ones? So we're trying the 7s. If we have 7, 2, 9 works because 18 minus 7 is 11. So 2, 9, 5, 6 obviously doesn't work. 4, 7 doesn't work because we have a 7 here and it's 3, 8. If this is 4, 18 minus 4 is 14. And that's not going to work then. 18 minus 4 is 14. And therefore, these two digits would have to add up to 14, which would be 5, 9, or 6, 8, which is not possible. So this has to be 7. So this is 7, which makes this 5, which makes that 4. And this is, so this adds up to 11. So these two must add up to 7. 11 minus 4 is 7. And we can't have 1, 6 here because of a 1, 6 here. We can't have 1 and 6 being here, which eliminates 1, 6 as a possibility here. Cannot be 3, 4, obviously, so this has to be 2 and 5. And then this must be 2, this must be 5. That eliminates 2, 9 here. So this must be 3, and this must be 8. 2 eliminates 2 here, so it's 1 and 2. This can't be 8, so this can't be 2. This can't be 3, so this can't be 7. This adds up to 20. And everything else is pretty much normal Sudoku, I think. We still have these that we have to add up. 14s. Okay. And this 20, but that's going to be a pain. Okay, let's look at column 7, because that has the most digits we have filled out. So we need 1, 4, 9. Obviously, 4 cannot be here, so this must be 4 here. That leaves us as 1 and 9 here. This can't be 1 here because of the 1 in the row. So this is 9, that's 1. Okay. That means this can't be 9 here. 1 has to be one of these two. Oh, that's interesting. So 1 is guaranteed to be in one of these 14 cages. How do you add up to 14 with a 1? It could be 1, 4, 9, 1, 5, 8, or 1, 6, 7. Interesting. Okay. Let's look at remaining digits in column 8 for now. We have 1, so it's 3, 6, 7, 9. And 9 cannot be any of these. So this is 3, 6, 7 as a triplet, which means this has to be 9 here. That leaves in box 8, 2, and 8. This can't be 2 because of 2 in the row. So this is 8, which makes this 2. That means the remaining digits in column 9 are 1, 6, and 7. And this can't be 1 or 6 because of 1 and 6 in the row, so that's 7. This can't be 1 or 7, so that's 6, which makes this 1. Interesting. Okay, remaining digits in... This can't be 6 or 9. This can't be 5. Remaining digits in row 4. We have 3, 4, and 9. Okay. And this can be 3 or 9 here. So we are guaranteed a 2 in this cage here. Huh. Okay. One of these is a 1 guaranteed. 9 has to be one of these 3. Okay. Remaining digits. So this adds up to 20. It does not have a 1. 5 unique digits adding up to 20 without a 1 must be 2, 3, 4, 5, 6. So this cannot be 7 or 9. This is a 6. This cannot be... Wait, that's not going to work. That's not going to work. Because that eliminates 3 and 4 here. Dang it. I was so close. Now I'm so far. So this is all correct. Right? 24 is in the 3-to-1 ratio with 8, 4-to-1 ratio with 6, 3-to-1 ratio with 8. 14 is 7 away from 7. 36 is in a 9-to-1 ratio with 4. 11 has a difference of 8 with 3. 3 is in a 1-to-5 ratio with 15. 3 is in a 1-to-6 ratio with 18. 18 has a difference of 3 with 15. 15 has a difference of 5 with 10. 10 has a difference of 8 with 18. But then we run into this problem with 25. Oh, it's 25. Okay, it's 25. Okay, good. Okay, good. Yeah, this is 5 and 25. Oops. So it cannot be 7 and 35 because of the reasoning we had. So this is 25. Okay, good, good. We're fine. We're fine. This could be higher than 6. So never mind. It's 25. I guess we have to keep filling in digits. Let's look at row 6. That means we have left 2, 3, 5, 7, 8. Obviously 5 and 8 cannot be here. So, and this cannot be 2. So 2, 3, 5, 7, 8 here. With a guaranteed 8 being one of these 3. We guaranteed 1 here. If this is 1, this is 7, and that's 6. That works. If this is 1, this cannot be, this has to be 7 here, and that would be 6. But that doesn't work. Because it can't have 6 there. Can't be 1 with 2 or 3, because that doesn't add up to 14. 1 and 3 add up to 4, that would make that 10. So this has to be 1. So this is 1, this is 7, that's 6, which eliminates 1 here. This is 8, this is 1. 6 eliminates 6 here, so it's 9 and 6. 9 eliminates 9 here. So this can't be 7, no 7 here, no 7 here. This is not 1. So to add up to 14 without 1, 5, 6, or 4... you have to have 2 and or 3. I think you have to have both. Can you not have 2 and 3? Well, actually, you also have to have 9 guaranteed, because 9 cannot be any of these cells because of 9 in the box in column 3, and it has to be then 9 here. So this is 9, which eliminates 9 here. Where is 9 in column 4? Can't be here or here because 9's in the rows, and can't be 9 here and here because 9's in the rows. So this must be 9. This cannot be 6 or 8 because of 6 or 8 in the row. This can't be 6. We have a 3, 4, 3, 4 pair in row 4, which eliminates 3 and 4 in the rest of the row. This can't be 3. This is 9, which makes this 6, which makes this 9. This must be 9 plus 2 and 3, adding up to 5. Or 5 plus 9 is 14. So this can't be 2 because of 2 in the row. So this is 3, which makes this 2. So this cannot be 2. Therefore, we have a 3, 5, 8 triplet in box 5, which eliminates 3, 5, and 8 in the rest of the box. This can't be 3 and 7. This is 4 and 6, which makes this 7. This can't be 5. This 7 eliminates 7 here. So this is 5. which makes this 8. This can't be 5, 7, or 8, so it's 6. This 8 eliminates 8 here, so it's 3 and 5. So this adds up to 15, which means these two digits must add up to 10. 25 minus 15 is 10. And this is 2, so this must be 8. Okay. That leaves this digit as a 4, which makes that a 3. That leaves this as 5. This 8 eliminates 8 here, so it's 7 and 8. This can't be 3. We have 6 and 7 remaining in row. Actually, let's do that. That's 2. This 6 eliminates 6 here, so this must be 6 here, which makes this 7. We have 7 and 8 remaining in column 3. This can't be 8 because of this 8 in the row, so this is 7, which makes this 8. 7 eliminates 7 here, so it's 3 and 7, which leaves this as a 3. And that's the solve. Yeah, I kind of not messed up, but had a bad multiplication here. But fortunately, I didn't go down that path. Well, I was basically like, wait, we have a contradiction here. And then I re-evaluated it and was able to find that this had to be 25 instead of 20. Very interesting, actually. This was a very interesting use of, well, it's a very interesting rule set I've never run into. But it's pretty cool, actually. Obviously, trying to figure this out was the key. And I felt that it was going to be, because this is a very unique ratio, right? And then this was also unique about how it could be. So this was very restricted. I think it actually just had to be in this ratio, right? There's no other way you can have this. I think just it wouldn't work any other way, right? You can't have, as we showed, we can't have 4 and 2 there. Yeah, it was just problematic. Running 4 and 2 as the ratios. Because the 2 had to be double. The 2 plus another number would have to be double what. Why was that? Yeah, it was 2. The reasoning was this could not be 6. Or that? No, that was not right. 4 and 1. 2 and 8. The problem was this was basically 10, right? So you had 4, 1. You cannot have, obviously, 4, 2. 4, 3 is 7, and 2 plus another number is never going to add up to 14, which is what 7 times 2 is, right? And it would have to be double, essentially, this value of the 4. So that was never going to work. And then we tried 4 and 1, and that doesn't work, even with 2, 8, because 4, 1 in a 4 to 1 ratio is 5 times 4, which is 20. 20 plus 10 plus 10 plus 5 is 35. So that would force this to be 10. So this pattern essentially is guaranteed to have to be something like this. And then this 1 to 2 ratio guaranteed this could not be 3, 5. So that was essentially, this was the break-in, essentially. Yeah, interesting little puzzle. Yeah. This was obviously the limiting factor. But I mean, you could use this rule set is interesting and potentially usable in the future, right? Yeah. It's just that like the break-in would be different, probably. Because the thing is once you figured this out, it's like there's no other break-in you can really have, right? Or you guaranteed you know what these digits have to be in this for ratios here, like that, right? But, I mean, obviously, you just don't use that in future puzzles. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.